By 1953, Hatfield Aerodrome employed over 7,000 workers building the world's only jet airliner. The de Havilland Comet flew higher, faster and quieter than anything America had. Britain held a lead of 3 to 5 years on the rest of the world. Then the aircraft started breaking apart in mid-air. A flaw hidden in the metal, at the corners of square windows in rivet holes punched rather than drilled, killed 99 people and grounded the fleet. While Britain investigated, Boeing built the 707. The company was absorbed, the name erased, the factory merged into British Aerospace, and then closed. The runway was dug up in 2001. Today, the flight test hangar is a leisure centre. The headquarters is a police station. The memorial to the founder sits behind security glass. This is the story of Geoffrey de Havilland, a curate's son who taught himself to fly, who built an empire from Hertfordshire farmland, who put Britain at the front of the jet age, and who lost it all to a crack 1/10 of a millimetre wide. What was built at Hatfield took 40 years. What destroyed it was invisible to the naked eye. Chapter 1. The curate's son who learned to fly. The story begins with a boy who hated school, loved moths, and couldn't stop drawing machines. Geoffrey de Havilland was born on the 27th of July, 1882, at Magdala House in High Wycombe, Buckinghamshire, the son of an Anglican curate described by those who knew him as irascible, improvident, and perpetually short of money. His mother Alice suffered what biographers carefully called a depressive decline. The family kept a household staff and 2 gardeners on a clergyman's wage, which tells you everything about the impossible mathematics of Victorian respectability. The boy was expected to follow his father into the clergy. He refused. He was sent to St Edward's School in Oxford and later wrote that he never cared for the place. The only world that mattered to him was his grandfather's farm at Medley Manor in Oxfordshire. Jason Saunders, a farmer, the most important figure in his early life, and eventually the man who'd bankroll the whole dream. De Havilland enrolled at the Crystal Palace School of Engineering in 1900. He described the workshop methods as archaic even for those days, but loved the work itself. The lathes, the hand tools, the act of making something real from drawings on paper. In his spare time, he designed a 450cc motorcycle engine, sold the drawings to 2 fellow students. They founded the Blackburn Engine Company with them. He was 18. What followed was a restless apprenticeship in unhappiness. He built steam turbines at Willans and Robinson, drew motorcar components at Wolseley and Birmingham for 30 shillings a week. Dull work, harsh management. Then bus design at the Motor Omnibus Construction Company in Walthamstow, where the one thing of lasting value he found was a Cornish mining engineer called Frank Hurl. Hurl would become his brother-in-law, his lifelong partner, and the man who held the practical side of the business together for decades. In 1905, his brother Ivan died. He was 26. Biographers note simply that for Geoffrey, the loss was overwhelming. The personality that emerges from the record is not a businessman. He had, by his own admission, no head for figures. He was an artist-engineer whose conviction was that, to be right, a design must look right. He collected moths and butterflies with a passion that bordered on obsession, and that love would give names to the most famous aircraft Britain ever produced. Then came the moment everything changed. In 1908, Wilbur Wright demonstrated powered flight at Le Mans, and Geoffrey de Havilland decided he was going to build an aeroplane. He'd never seen one. He'd never sat in one. He'd certainly never flown one. But he went to his grandfather at Medley Manor and asked to borrow £1,000, an enormous sum. Jason Saunders handed it over with one condition: there'd be nothing later. De Havilland and Hurl rented a workshop at Bothwell Street, Fulham, for £1 a week. His wife Louie, a former governess he'd married the year before, sewed the fabric for the wings at the kitchen table. They built the entire aircraft without ever having seen a real one up close. He crashed it. December 1909, at 7 Barrows on Lord Carnarvon's estate near Lichfield. The machine was wrecked. De Havilland walked away, pulled the engine from the wreckage, and started again. On the 10th of September 1910, he flew successfully from a meadow near Newbury. sold the aircraft to the balloon factory at Farnborough for £400 and secured employment for himself and Hurl in the bargain. At the Royal Aircraft Factory, he designed the BE-2 series and set a British altitude record of 10,500 feet. A fog incident left a deep mark. He recalled that the moment the wheels left the ground, he could see nothing, and then chimney pots on houses suddenly appeared through the murk. During the war, as chief designer at Airco under the industrialist George Holt Thomas, he produced the DH-4, considered by many to be the finest single-engined bomber of the conflict. He prospered on royalties, but by late 1918 the pressure broke something inside him. He suffered a nervous breakdown. He was 36 years old. He'd designed aircraft that helped win a war. And now the company that employed him was about to be sold to a firm that had no interest in aviation whatsoever. Chapter 2. Moths over England. When Airco collapsed in 1920, bought by BSA, who wanted the factory floor space, not the aircraft, Geoffrey de Havilland did the only thing that made sense to him. He started his own company. The de Havilland Aircraft Company was registered on the 25th of September 1920, with nominal capital of £50,000. Geoffrey put in £3,000 of his own. George Holt Thomas, his former patron, contributed £10,000. They took over premises at Stag Lane Aerodrome in Edgware with about 60 former Airco employees. First year turnover, £32,782. Net profit, £2,387, enough to survive. Barely. The founding team was small and tight. Charles Clement Walker as chief engineer, Frank Hurl running the works, Arthur Hagg heading the drawing office, where he pioneered the lightweight composite wooden construction that would prove decisive 20 years later, Francis St. Barb handling sales. And then the crucial recruit, Alan Samuel Butler, a wealthy sportsman who approached de Havilland wanting a new aircraft in 1921, invested heavily and became chairman in 1924. Butler's money and business sense freed Geoffrey to do the only thing he was truly built for: design. The DH-60 Moth, first flown by de Havilland himself on the 22nd of February 1925, transformed British aviation overnight. A compact two-seat biplane powered by Frank Halford's Cirrus engine, it was small enough to land in a field and cheap enough to launch the flying club movement across the country. Amy Johnson flew a Gypsy Moth variant solo to Australia in 1930. Over 8,000 Moths of all variants were eventually produced. The DH-82 Tiger Moth, first flight October 1931, became the standard RAF elementary trainer. Some 8,800 were built across factories in Britain, Canada, Australia and New Zealand. Nearly half of wartime UK production was contracted out to Morris Motors at Cowley, Oxford, to free capacity at the place that was now becoming de Havilland's true home. Hatfield. De Havilland had purchased farmland near Harpsfield Farm in 1928. Flying commenced in June 1930. By 1933, there were clubhouse buildings, a swimming pool, squash courts, tennis courts. In 1934, large factory buildings went up alongside an imposing Art Deco administration block designed by James M. Monroe and Sons of Glasgow. Stag Lane closed to flying the same year. The Hatfield of the 1930s was glamorous. Movie stars and celebrities frequented the London Aeroplane Club. Alex Henshaw celebrated winning the 1938 King's Cup air race at the Comet Hotel nearby, a building designed to resemble an aeroplane, complete with a cockpit bar. And then came the aircraft that proved what de Havilland's wooden construction methods could really do. The DH-88 Comet Racer. 3 built in just 10 months at £5,000 each for the 1934 McRobertson Trophy. Air race from Mildenhall to Melbourne. On the 20th of October, before 60,000 spectators, Grosvenor House, piloted by CWA Scott and Tom Campbell Black, won the race in 2 days and 23 hours, flying the last stage on one throttled-back engine. The stressed wooden monocoque construction and aerodynamic cleanliness that made that victory possible would become the DNA of something far more important. Chapter 3. The Wooden Wonder Goes to War. In 1938, Geoffrey de Havilland sat down and wrote a letter to Air Marshal Wilfred Freeman. His argument was simple. Wood was plentiful. Aluminium and steel would be scarce in wartime. He proposed an unarmed twin-engine bomber built almost entirely from wood, so fast it would need no defensive armament at all. The Air Ministry thought it was mad. Backward. The project was dubbed Freeman's Folly, and only Freeman's personal insistence kept it alive. Chief designer Ronald Eric Bishop, who'd joined de Havilland as an apprentice in 1921 at the age of 18, led a small team that moved in October 1939 to Salisbury Hall, a 17th-century moated manor house 6.5 miles from Hatfield, once associated with Charles II's mistress Nell Gwynn. The secrecy was deliberate. The aircraft they were building was unlike anything the RAF had seen. The DH-98 Mosquito was constructed from Alaskan spruce, English ash, Canadian birch, and Ecuadorian balsa, bonded together with casein glue. 2 fuselage halves were moulded as plywood balsa plywood sandwiches and joined down the middle. The subcontractors weren't metal workers. They were cabinet makers, piano builders, furniture companies from High Wycombe. The skills that built drawing room sideboards were now building a weapon of war. The prototype first flew from Hatfield on the 25th of November 1940, piloted by Geoffrey de Havilland Jr., the boss's eldest son. On the 16th of January 1941, it outpaced a Spitfire in trials, reaching 437 miles per hour. The fastest operational aircraft in the world. It held that distinction for 2.5 years. The Mosquito served in over 30 variants: bomber, fighter, reconnaissance, pathfinder, maritime strike. BOAC even carried passengers in the bomb bay on fast transport runs. On the 30th of January 1943, Mosquitoes knocked out the Berlin broadcasting station while Hermann Goering was speaking. His outburst became famous. He said the Mosquito made him furious, that he turned green and yellow with envy. The bomber variants ended the war with the lowest loss rate of any aircraft in Bomber Command. A total of 7,781 were built. Approximately 3,300 assembled at Hatfield, where the wartime workforce exceeded 7,500. The factory had already been targeted. On the 3rd of October 1940, a lone Junkers Ju-88 dived to 50 feet and dropped 4 bombs, destroying the assembly shop, killing 21 workers and injuring 70. The Mosquito prototype was in development at Hatfield at the time. It flew just 53 days later. De Havilland paid for the war in ways no factory output could measure. His youngest son John was killed on the 23rd of August 1943, when his Mosquito collided with another near St Albans. All 4 occupants of both aircraft died. His eldest son Geoffrey Jr., the man who'd flown the Mosquito prototype, the test pilot who'd proved the whole concept, was killed on the 27th of September 1946, when the experimental DH-108 Swallow disintegrated over the Thames estuary at approximately 637 miles per hour. His body was found on mudflats at Whitstable. The parachute ring was untouched. Captain Eric Brown, who survived similar oscillations in the same aircraft type, later suggested that Geoffrey Jr.'s height made it impossible for him to reach the canopy release. A father who built the fastest aircraft of the war, who buried both his sons because of aircraft, and who, even after that, kept building. Chapter 4. Higher than the Weather. The Brabazon Committee, formed on the 11th of March 1943, while the war was still very much being fought, had been tasked with planning Britain's post-war airline needs. Among their recommendations was a Type 4 specification, a jet-propelled mailplane for the North Atlantic. Sir Geoffrey de Havilland personally championed the turbojet concept against widespread scepticism. Most experts believed jet engines were too thirsty, too unreliable, too new. De Havilland believed they were the future. In February 1945, his company received the contract. Ronald Bishop, the same man who'd designed the Mosquito, led the design team again. They explored canard layouts, flying wings, tailless configurations, before settling on a conventional swept-wing design with 4 de Havilland Ghost. 50 turbojet engines buried in the wing roots. The aircraft was named the DH-106 Comet in December 1947. What they were attempting was staggering. The world's first highly pressurized commercial cabin, 8¼ pounds per square inch, enabling flight at 35 to 40,000 feet. The first totally hydraulically powered flight controls on a passenger aircraft. Redux adhesive bonding of skin panels. BOAC requested the cabin be enlarged from 24 to 36 seats in 4 abreast configuration. The Comet could cruise at 490 miles per hour. The Douglas DC-6, the best piston airliner America had, managed 315. The Comet flew above the weather that competitors endured, in a cabin so quiet that passengers accustomed to the shuddering drone of propeller aircraft couldn't quite believe it. Hatfield had become something extraordinary. The aerodrome sprawled across hundreds of acres of former Hertfordshire farmland, bisected by a 6,000-foot concrete runway aligned roughly east-west. The Art Deco administration block fronted Comet Way. Behind it stretched vast single-story steel factory buildings covering 190,000 square feet. A new flight test hangar, completed in 1952, was the world's largest permanent aluminium building, 217 feet wide, 330 feet long, 45 feet high. Across the runway, the Manor Road site housed the de Havilland Engine Company, with wind tunnels, water tanks and jet engine test facilities whose scream could be heard across the county. The sensory world of that factory had transformed. In the Mosquito years, the workshops had smelled of birch plywood, casing glue and aircraft dope. Now it was aluminium, the acrid tang of metal being cut and worked, the clatter of rivet guns, the whir of drills echoing off the steel-framed buildings. And underneath it all, the new sound that announced a new age, the shriek of ghost and goblin jet engines during test runs. 130 to 140 decibels. Workers near the test beds described it as something you felt in your chest before you heard it in your ears. The ground shook. Dick Whittingham, who'd begun his apprenticeship in 1935 and spent decades in the experimental department, remembered the factory's social fabric. The splicers were all Welsh miners who'd come to Hatfield after losing their jobs. The fitting shop was full of men from Swindon, refugees from the railway works closing down. There was the Swindon mob and the Welsh mob, and then there were the Glaswegians. Arthur Ball, a sheet metal worker from the Grimsby shipyards, recalled something simpler. When he arrived at Hatfield, there was soap when you went to wash your hands. Soap. And if he walked over to the sports club, he could get a shower. He'd never been in a shower before, so it was marvellous to him. On the 27th of July, 1949, a date that was both test pilot John Cunningham's 32nd birthday and Sir Geoffrey's 67th, the Comet prototype lifted off from Hatfield. Cunningham was the RAF's highest-scoring night fighter pilot, 20 kills, known as Cat's Eyes, from a wartime propaganda story about eating carrots. He said later that he didn't think it was too much to say that the world changed from the moment the Comet's wheels left the ground. He wasn't exaggerating. Chapter 5. The World at 35,000 feet. At 12 minutes past 3 on the afternoon of the 2nd of May, 1952, a de Havilland Comet designated GALYP, known by its call sign Yoke Peter, departed London Heathrow carrying 36 passengers and 30 bags of mail. Destination: Johannesburg via Rome, Beirut, Khartoum, Entebbe and Livingston. Captain A.M. Majendi commanded the first leg. Between Rome and Beirut, the aircraft set a speed record of 525 miles per hour. The service arrived 14 minutes ahead of schedule. A young South African named Stephen Nod had been given a mercy seat, a spare place offered at the last moment so he could reach his dangerously ill mother. It was the world's first scheduled jet passenger service. Nothing like it had ever happened before, and Britain had done it. The press on both sides of the Atlantic understood what they were witnessing. American Aviation magazine wrote that the British were giving the United States a drubbing in jet transport, whether America liked it or not. Popular Mechanics declared Britain held a lead of 3 to 5 years on the rest of the world. Orders began flooding in, from BOAC, Air France, UAT, Canadian Pacific, and even American carriers were circling. By the summer of 1953, 8 BOAC Comets departed London every week, bound for Johannesburg, Tokyo, Singapore, and Colombo. Over 30,000 passengers flew in the first year. Prince Philip flew on a Comet. So did the Queen Mother and Princess Margaret. Round-trip tickets cost £315, roughly $8,000 in today's money. De Havilland wasn't simply building aircraft. The company had built the town. By 1952, 65% of all workers in Hatfield were employed by de Havilland or its subsidiaries. The technical school, founded in January 1935, had evolved through Hatfield Technical College. Opened September 1952 on 90 acres donated by Chairman Alan Butler, enrolling over 1,700 students, into what would eventually become the University of Hertfordshire. The sports clubs, the Bowls Club founded in 1937, the cricket teams, the rugby clubs, all bore the de Havilland name. Housing was built for workers. The canteen had its own strict social hierarchy. Workers downstairs, managers upstairs. Thomas Brown, who'd worked in the experimental department since 1945, was small enough to be used fitting fuel tanks inside the wings of early Comets, crawling into spaces that larger men couldn't reach, connecting fuel lines by feel in the dark interior of a wing designed to carry passengers at 35,000 feet. During a strike, artisans who normally painted aircraft names took their skills to the picket line, using the same typeface to make the workers' protest signs. A detail that tells you everything about the pride in that place. Hatfield, in the summer of 1953, was the most advanced commercial aerospace facility on Earth. The Comet was years ahead of anything America could offer. The order books were filling. The workforce was confident. The nation was proud. Britain had invented the jet age, and the jet age lived at Hatfield. And somewhere in the aluminium skin of those beautiful aircraft, in a place no one had thought to look, at a scale no one had thought to measure, a crack had already begun to grow. Chapter 6. Something Falling from the Sky. The first warning came on the 3rd of March, 1953. A Canadian Pacific Comet 1A, registration CF-CUN, crashed on its delivery flight at Karachi, Pakistan. All 11 aboard were killed. It was the first fatal jetliner crash in history. The cause was a ground stall on takeoff, not structural failure, but the shockwave it sent through the industry was real. The aircraft that was supposed to be years ahead of everything suddenly had a body count. Then came the 2nd of May, 1953, exactly 1 year to the day after the Comet's triumphant inaugural service. BOAC Flight 783, registration GALY5, broke apart near Calcutta 6 minutes after takeoff. 43 people died. The investigation concluded that the aircraft had suffered structural failure in severe turbulence. Approximately 60 modifications were made to the Comet fleet, including the first artificial control feedback system, what engineers called Q-Feel, a mechanism to give pilots a sense of the aerodynamic forces acting on the controls. The fleet returned to service. The problem, everyone agreed, had been identified and fixed. Everyone was wrong. On the 10th of January, 1954, BOAC Flight 781 departed Rome for London. The aircraft was G-ALYP, Yoke Peter, the very same Comet that had operated the world's first commercial jet flight 20 months earlier. Captain Alan Gibson, 31 years old, was in command. As the aircraft climbed through 27,000 feet over the Mediterranean near Elba, Gibson radioed a BOAC Argonaut flying below. His last words were the beginning of a routine call. "George How Jig from George Yoke Peter, did you get my—" His voice cut off mid-sentence. The fuselage roof ripped open. Explosive decompression tore passengers from their seats, slamming them against structure. The aircraft disintegrated. 35 people were killed, including 10 children and Chester Wilmot, the renowned Australian war correspondent whose book The Struggle for Europe remains a classic of military history. Wreckage fell into the Mediterranean off the Italian island of Elba. scattering across the seabed at depths of 130 to 180 metres. BOAC voluntarily grounded the fleet. A committee was formed, chaired by Charles Abel of de Havilland, to investigate. They listed possible causes and proposed modifications. But fatigue of the pressurised fuselage was not among the causes they considered. Not at this stage. The committee concluded that modifications to the fuel system, the flight controls, and the structure around the wing would address the likely failure modes. After those changes were made, Comets returned to passenger service on the 23rd of March, 1954. Sir Miles Thomas, BOAC's chairman, appeared on television. He said that BOAC obviously wouldn't be flying the Comet with passengers if they weren't satisfied conditions were suitable. 16 days. That's how long the reprieve lasted. On the 8th of April, 1954, South African Airways Flight 201AB OAC-owned Comet on charter, registration GALYY, broke apart near the volcanic island of Stromboli after departing Rome. All 21 aboard were killed, including South African captain Wilhelm Karel Mostert and his full crew. The same team of BOAC engineers who had inspected Flight 781 before its final departure had also cleared this aircraft. 2 Comets. The same departure airport. The same stretch of Mediterranean sky. The same catastrophic in-flight disintegration. The same silence where a radio call should have been. BOAC grounded every Comet immediately. This time, permanently. On the 12th of April, the Minister of Transport, Alan Lennox Boyd, formally withdrew the certificate of airworthiness from all Comet aircraft. Production at Hatfield was suspended. The assembly lines fell quiet. The most advanced commercial aircraft in the world was forbidden to carry a single passenger. 99 people were dead from structural failures alone, and nobody knew why. Chapter 7. The Tank at Farnborough. The investigation fell to a 39-year-old Cambridge-educated engineer named Sir Arnold Hall, Director of the Royal Aircraft Establishment at Farnborough, Fellow of the Royal Society, the youngest man ever to hold the post. What he designed over the following months would become the template for every major aviation investigation that followed. First, the wreckage. Admiral Lord Mountbatten oversaw Royal Navy salvage ships that recovered approximately 70% of Yoke-Peters' remains from the Mediterranean seabed. It was the first underwater recovery of a crashed aircraft at such depth, and it employed the first ever underwater television camera used in crash investigation. Divers worked at 130 metres, sending footage to the surface in grainy black and white. Pieces of fuselage skin, shattered window frames, fragments of seats, all hauled up and catalogued and laid out in a vast hangar at Farnborough like an aluminium jigsaw puzzle. But Hall knew the wreckage alone wouldn't answer the question. He needed to reproduce the failure. So he ordered something no one had attempted before. BOAC donated an identical Comet airframe, GALYU, which was trucked from Hatfield to Farnborough and lowered into a specially constructed water tank holding 200,000 gallons. The wings protruded through sealed walls on either side. The fuselage was filled with water and then repeatedly pressurised to simulate flight at 35,000 feet, then depressurised, each cycle taking approximately 3 minutes, running 24 hours a day. Water was chosen deliberately. Air pressurisation would have caused explosive destruction, exactly as in the actual crashes, making analysis impossible. Water acted as a damper. It allowed cracks to develop and propagate without catastrophic fragmentation. The engineers could watch failure happen in slow motion, cycle after cycle, day after day, week after week. The tank hummed and pressurised and depressurised 3 minutes at a time around the clock. On the 24th of June 1954, after 3,057 total pressure cycles, 1,221 actual flights plus 1,836 simulated, the fuselage burst open. The fracture started at the corner of the forward escape hatch window cutout and extended for 8 feet along the fuselage skin. And when the engineers examined the torn metal under magnification, they found what they'd been looking for: metal fatigue. the slow, progressive breakdown of aluminium under repeated pressurization cycles, invisible to the naked eye until the moment it becomes catastrophic. Meanwhile, a critical piece of wreckage recovered from the Mediterranean seabed confirmed it. A section of Yoke-Peters' fuselage roof showed a fatigue crack originating at a countersunk rivet hole at the starboard aft corner of the rear automatic direction finder. Antenna window. The initial defect was approximately 100 micrometers, a tenth of a millimeter. Barely visible even under magnification, the RAE investigators called it the unmistakable fingerprint of fatigue. The technical failure was devastating in its specificity. De Havilland's engineers had calculated maximum stress around the window corners at £28,000 per square inch, against an ultimate material strength of 65,000. The numbers looked safe. They weren't. Actual stresses at the corners were far higher than calculated. Square and rectangular cutouts concentrate stress at their corners by a factor of 2 to 3 times compared with the surrounding skin. Round or oval openings distribute stress evenly. The Comet's windows were square, and the construction had compounded the flaw. The windows had been punch-riveted rather than drill-riveted as originally specified, a cruder method that left microscopic irregularities at each hole, each one a potential initiation point for a crack. The redux adhesive bonding originally called for in the design had been omitted during production. Yoke-Peter had completed just 1,290 pressurized flights, far short of the 10,000 flight design life. The aircraft hadn't even reached 13% of the cycles it was supposed to withstand. The Court of Inquiry opened under Lord Cohen, Baron Cohen, of Walmer, a former High Court judge. The report, published the 1st of February 1955, found that the Comet's basic design was sound and that de Havilland had been working at the very limit of scientific knowledge. De Havilland's counsel made a statement that has echoed through aviation history ever since. The cause of the accident, he said, was the adventurous pioneering spirit of our race. It was metallurgy, not aeronautics, that was in the dock. The inquiry recommended a fundamental shift from safe life structural design, where components are expected to last a specified number of cycles, to fail-safe design, where structures include redundancies and alternate load paths so that a single crack cannot bring down an aircraft. Britain published all findings openly. The entire global aviation industry learned from the Comet's tragedies. Every jetliner that has flown since, every Boeing, every Airbus, every aircraft carrying passengers at 35,000 feet, carries the lessons written in the lives of those 99 people. The Comet's passengers didn't die for nothing, but they died because what the engineers didn't know was hidden inside the metal itself. Chapter 8. The Quiet Man. From Seattle. While Britain mourned and investigated, a man in Seattle was already moving. In the summer of 1950, Boeing's president William Allen had led a delegation to Britain. They visited the Farnborough Air Show. They toured the de Havilland factory at Hatfield. They saw the Comet. And what they saw galvanised everything that followed. On the 20th of May, 1952, just 18 days after the Comet's inaugural commercial flight, Boeing's board approved a prototype designated the 367-80. They called it the Dash 80. Allen committed $16 million of company funds, roughly 2/3 of Boeing's entire post-war net profits. It was an enormous gamble, though substantially cushioned by the near certainty of a United States Air Force tanker contract. The KC-135 eventually yielded 732 military orders, and that river of government money underwrote the entire commercial program. De Havilland had no equivalent safety net. Britain's military contracts were smaller, its domestic market a fraction of America's. De Havilland was a private company betting everything on commercial success. The Dash 81st flew on the 15th of July, 1954, just 3 weeks after Arnold Hall's water tank ruptured at Farnborough. Test pilot Alvin Johnston, known as Tex, and co-pilot Richard Lush flew for 2 hours and 24 minutes. Johnston said she flew like a bird, only faster. At a hydroplane race on Lake Washington the following August, Tex Johnston barrel-rolled the 4-engine prototype in front of airline executives. William Allen, watching from a boat below, was reported to be in medical distress. Johnston's defence was simple. He was selling aeroplanes. Boeing built systematically on the Comet's lessons, and they did so with the precision of an organisation that had watched someone else make the mistakes first. Round and oval windows replaced square ones. Fuselage skin was specified at a significantly thicker gauge, and Boeing had made that decision months before the Comet's vulnerability was publicly confirmed. They adopted the fail-safe structural philosophy that Farnborough's inquiry was about to recommend. Redundancies, alternate load paths, crack-stopping provisions at every critical joint. They staged a public demonstration called Operation Guillotine, 5 giant blades piercing a fully pressurised fuselage. The result was wisps of escaping air. No cracks, no failure, no catastrophe. Engines were mounted on underwing pylons rather than buried in the wing roots, reducing the risk that an engine fire could destroy the wing structure. Leading-edge Kruger flaps were added specifically in response to the Comet's takeoff accidents. Every lesson that Hatfield's tragedies had taught, Boeing absorbed and applied. They were building on a foundation of grief that wasn't theirs. The specifications gap was brutal. The Boeing 707-12 seated 137 to 174 passengers in 6 abreast configuration. The Comet 4, de Havilland's redesigned version, with oval windows, thicker skin and Rolls-Royce Avon engines, seated 56 to 81 in 4 abreast. The 707 was faster, 550 to 600 miles per hour against the Comet's 490 to 530. It flew further. And it could carry 2 to 3 times the passengers, which meant dramatically lower cost per seat. The Comet 4 was a fundamentally smaller aircraft trying to compete in a larger aircraft's market. The moment that sealed it came on the 13th of October, 1955. Juan Trippe, Pan American's legendary chairman, announced orders for 20 Boeing 707s and 25 Douglas DC-8s, a combined value of $269 million. That single announcement forced every competitor airline on Earth to rush to buy American jets or face obsolescence. American Airlines chief executive C.R. Smith told Boeing he wouldn't buy unless the fuselage was an inch wider than the DC-8. Boeing obliged. The final width was fixed at 148 inches. De Havilland's Comet 4 did technically win the transatlantic race. On the 4th of October 1958, 2 Comets departed simultaneously from London and New York. Captain Tom Stoney flew eastbound non-stop in just 6 hours and 12 minutes. The New York Times headlined that the British were gloating, but the victory was hollow, a consolation prize mistaken for a trophy. The Comet 4 couldn't fly non-stop westbound into the prevailing headwinds. Pan Am's 707 service followed 22 days later with twice the passengers and the range to make it both ways. By October 1960, BOAC, Britain's own flagship carrier, had withdrawn Comets from the Atlantic and replaced them with Boeing 707-42s. Airlines that had ordered Comets switched to Boeing. Pan Am, Japan Airlines, National Airlines, Pan Air do Brazil. The final production numbers are the epitaph. 114 Comets built, all variants. 1,010 civilian Boeing 707s, plus 820 military KC-135 and C-135 variants sharing the same airframe. Britain had invented the jet airliner. America had taken the industry. Chapter 9. Death by Committee. If the Comet disasters destroyed Britain's lead, what followed made certain it could never be recovered. The 1957 Defence White Paper, authored by Duncan Sandys, the Minister of Defence and Winston Churchill's son-in-law, declared that manned fighter aircraft would be increasingly replaced by guided missiles and manned bombers by ballistic rockets. The paper projected 100,000 job losses from a peak aerospace workforce of approximately 400,000, and it mandated consolidation. New contracts would only go to merged firms. The supersonic interceptor program was cancelled. Saunders-Roe's mixed-power fighter was cancelled. Avro's bomber was cancelled. Only the English Electric Lightning survived. The white paper was catastrophically wrong. Manned combat aircraft remained essential through every subsequent conflict, from Vietnam to the Falklands to Afghanistan. But the damage was irreversible. The directive to merge had the force of policy, and the mergers began. In 1960, Sir Thomas Sopwith, chairman of Hawker Siddeley, acquired de Havilland, along with Folland and Blackburn Aircraft, to create a consolidated aerospace group. Sir Aubrey Burke was chairman of de Havilland at the time. Sir Geoffrey, who had retired from active involvement in 1955, saw his role cease entirely. He wrote his autobiography, Sky Fever, in 1961, referring with careful nostalgia to what he called the friendly and cooperative atmosphere in the company. He received the Order of Merit from the Queen in 1962. He died on the 21st of May, 1965, aged 82, of a cerebral hemorrhage. His ashes were scattered over Seven Barrows, where he'd made his first flight in 1910, from a DHAE 121 Trident flown by John Cunningham. By 1963, the de Havilland name had been extinguished from every product. Everything was rebranded Hawker Siddeley. The company that had built the Moth, the Mosquito and the Comet, the company that had put Britain years ahead of America in the jet age, no longer existed, even as a name on a fuselage. And then came the Trident. The aircraft that proved the disease wasn't just metal fatigue, it was institutional. De Havilland's original 1957 design for the DH-121 was a three-engined rear-mounted jet seating 111 to 140 passengers, powered by three Rolls-Royce Medway engines at 13,790 pounds of thrust each. It was essentially the same size class that Boeing would build as the 727. Airlines across Europe and beyond expressed interest. De Havilland's own sales department warned that the international market wanted the larger model. But Lord Douglas of Kirtleside, chairman of British European Airways, the airline that would be the launch customer, demanded the aircraft be shrunk. BEA feared declining passenger numbers. They wanted something smaller, cheaper, lower risk. De Havilland's board capitulated, overriding their own sales team's warnings. The engines were changed from Medways to the much smaller Rolls-Royce Spey at 9,850 pounds of thrust, a 40% reduction in power. Capacity fell to 88 to 95 seats. Then came what aviation historians have called the crowning piece of stupidity. Lord Douglas proposed that Boeing might co-manufacture the DH-121 in America. De Havilland invited Boeing engineers to Hatfield, where they were reportedly amazed at how openly the British shared virtually all their research, drawings and design data. When de Havilland's representatives visited Seattle in return, Boeing revealed almost nothing. Boeing subsequently changed its 727 design, adding more wing sweep, modifying the landing gear. The 727 was built as essentially the aircraft the DH-121 should have been. The result: 117 Tridents built. 1,831 Boeing 727s. BEA and its successor British Airways were virtually the only significant Trident customer, apart from China's CAAC, which bought 35. The aircraft de Havilland designed to compete with Boeing became the blueprint Boeing used to dominate. Further nationalisation followed. The Aircraft and Shipbuilding Industries Act of 1977 merged everything into British Aerospace, formed on the 29th of April that year. The Hawker Siddeley signs came down at Hatfield. New ones went up. The BAE 146, a quiet four-engined regional jet whose origins lay in de Havilland studies from the late 1950s, provided a lifeline. The first one flew from Hatfield on the 3rd of September 1981. 221 were assembled there between 1983 and 1992 in a new four-bay assembly hall. Marketed as the Whisper Jet, it was the most successful British civil jet programme since the Comet. It never reached its 250-unit break-even target. Chapter 10. The Last Aircraft Takes Off. By the early 1990s, British aerospace was hemorrhaging. Property losses from a subsidiary called Arlington Securities, declining Rover Group sales, defence spending cuts, the airline industry recession, everything converging at once. In September 1991, Chief Executive Richard Evans led what The Independent described as one of the most spectacular boardroom coups witnessed in many years, ousting Chairman Professor Sir Rowland Smith. In 1992, BAE wrote off £1 billion of assets, the largest corporate write-off in British history at that time, and cut 60,000 of its 127,000 workforce. 40,000 of those losses came from the regional aircraft division. The decision to close Hatfield came in stages. On the 12th of February 1992, BAE announced the transfer of all BAE 146 final assembly from Hatfield to Woodford. On the 23rd of September, the final decision was made public. All aircraft design and production at Hatfield would cease by the end of 1993. 3,000 jobs eliminated. Evans framed it in the language of survival. The company couldn't afford to carry two core businesses, cars and aerospace. A planned joint venture with Taiwan Aerospace Corporation, which would have injected £120 million, had collapsed, and the closure savings had become essential. Production wound down through 1993. The Manor Road site was cleared first. The engine test facilities fell silent. The wind tunnels were emptied. Then came the 8th of April, 1994. A DH Chipmunk, the same type that had made the first landing on the new runway decades earlier, was the last aircraft to take off from the main runway. It was followed by a tiger moth carrying a de Havilland flag, which lifted off from the grass beside the concrete strip. Public events had been held through the preceding days. Former workers came back. They walked the floor one last time. They stood where the mosquitoes had been assembled, where the Comets had been riveted together, where the Tridents had rolled out and the BAE 146s had taxied to the runway. And then Hatfield fell silent, as an airfield, for the last time. The employment numbers tell the story in three figures. Over 7,500 at the wartime peak. Approximately 4,000 in 1949, when the Comet first flew. Roughly 2,500 at closure. Before the bulldozers arrived, the derelict airfield found one last use. Steven Spielberg chose the empty site as a filming location for Saving Private Ryan. Later, the BBC and HBO filmed Band of Brothers there, the ghost of a place that had built aircraft for an actual world war, now serving as a set for fictional recreations of that same conflict. The runway was dug up in 2001. Most of the factory buildings were demolished. The concrete was broken up. The steel was cut and trucked away. Chapter 11. Street Signs and Spinning Classes. A master plan adopted by Welwyn Hatfield Council in November 1999 converted the 800-acre site into mixed-use development. Today, Hatfield Business Park holds 3.5 million square feet of commercial space, creating 10,000 jobs, more than worked at the factory at its wartime peak. But the jobs are in warehousing, logistics and generic offices, not aircraft. Over 2,000 homes have been built. The Galleria Shopping Centre, opened in 1991, is a glass structure deliberately shaped to resemble an aircraft hangar, straddling the A1M motorway tunnel beneath. It once displayed a replica DH-88 Comet racer hanging from the ceiling. It now has over 20 empty retail units. 2 original structures survive. The flight test hangar, once the world's largest permanent aluminium building, 217 feet wide, 330 feet long, 45 feet high, where Comets were prepared for their maiden flights and mosquitoes were tested before they went to war, is now a David Lloyd leisure centre and something called the Hangar Hotel. The building is Grade 2-star listed. The exercises have changed. The Art Deco administration block serves as Hertfordshire Police headquarters. It is inaccessible to the public. The memorial to Geoffrey de Havilland, originally placed in the entrance to the building he had commissioned, now sits behind police security. 6 memorial markers by sculptor Rod Coleman, funded by British Aerospace before it became BAE Systems, stand flanking the police station entrance. They detail the aircraft made at the site. Visitors are not encouraged to linger. The de Havilland name persists in the street signs with almost obsessive thoroughness. Comet Way, Mosquito Way, Dragon Road. Tiger Moth Way, Albatross Way, Cunningham Avenue, after John Cunningham, Cat's Eyes, the man who first flew the Comet, Bishop Square after Ronald Bishop, on the site where his office once stood, Hurl Way, after Frank Hurl, the Cornish mining engineer who'd been there from the very beginning, Tamblin Way, after William Tamblin, the mosquito wing designer, Barlow Close after test pilot Peter Barlow, killed in a Trident crash in 1966. One street is misspelled. Gypsy Moth Avenue uses a Y. De Havilland always used an I. The University of Hertfordshire's De Havilland campus, opened in September 2003 at a cost of £120 million, sits on part of the former airfield, a direct descendant of the technical school that Geoffrey de Havilland's company established in 1935. The actress Olivia de Havilland, Sir Geoffrey's first cousin, presided over the campus naming ceremony in 2002. At London Colney, the de Havilland Aircraft Museum, the oldest aviation museum in Britain, established in 1959 at the same Salisbury Hall where the Mosquito prototype was secretly designed, preserves over 20 de Havilland aircraft. 3 Mosquitoes, the only museum in the world with 3. A Comet fuselage you can walk through. Vampire variants. ABAE 146 section. It is volunteer run. Hatfield itself has struggled. The population grew from just under 30,000 in 2001 to over 41,000 by 2021, boosted by students, more than a quarter of all residents. But the economic base shifted from high-skilled manufacturing to services, retail and distribution. One national newspaper called Hatfield as bad as it gets. A £100 million regeneration plan fell victim to the 2008 financial crisis. Recovery has been slow. The town has a new identity now. It is a London commuter settlement. A former worker, asked about returning to the site, said something that needs no elaboration. He said he really struggled to go back to Hatfield now, and particularly avoided the former airfield. Here is what Britain lost, compressed into a single arc. Before 1957, more than 15 independent aircraft companies populated this country. The Sandys White Paper and government-forced mergers compressed them to 2 groups by 1960, then to 1, British Aerospace, in 1977, then to a defence firm called BAE Systems in 1999. In 2001, BAE closed Avro Regional Jet production at Woodford, the last British civil airliner ever built. In 2006, BAE sold its 20% stake in Airbus for £1.87 billion, ending direct British ownership in Europe's only challenger to Boeing. And here lies the deepest irony of all. Britain today makes every wing for every Airbus, at Broughton and Filton, employing some 13,000 people. That wing expertise was assigned to Britain specifically because of the advanced work done on the Trident, the aircraft designed by de Havilland engineers at Hatfield. Some of those same Hatfield engineers worked on early Airbus wing design before the facility closed. The capability survived. The company didn't. The name didn't. The place didn't. In 1930, a self-taught pilot bought farmland in Hertfordshire. By 1949, his company had built the world's first jet airliner. By 1963, his company's name had been erased. By 1994, the last aircraft left. By 2001, the runway was rubble. Where ghost engines once screamed at 140 decibels, you hear the beep of checkout scanners and the hum of motorway traffic. Where 7,500 workers built aircraft that changed the world. 10,000 people work in offices and warehouses. The flight test hangar echoes with spinning classes. The street signs at Hatfield remember. The concrete does not.